Lesson 10. Technology Subsystem, 3D Printing for STEM and Robotics Applications. Contents. The topics covered in this lesson are: Introduction to 3D Printing, History and Modern Era of 3D Printing, Process of 3D Printing, Types of 3D Printing. The task or activity for this lesson includes touring the MakerSpace. Introduction to 3D Printing. 3D printing is an additive manufacturing process that creates three-dimensional objects from three-dimensional design model. Three-dimensional digital models are sliced into many two-dimensional cross-sections that are then printed, one on top of the other. There are other digitized processes that are a subtractive manufacturing process, for example CNC milling, often referred to as machining. 3D printing is an additive method, that is, material is added, rather than taking it away. The material is layered using an extruder, onto a bed, with each layer bonding to the previous. The main difference between 3D printing and additive manufacturing is 3D printing is creation of objects by layering of material, whereas the latter creates objects by adding material, which may or may not come in layers. The main difference between subtractive and additive manufacturing is additive manufacturing processes build objects by adding material layer by layer, while subtractive manufacturing removes material to create parts. The process follows the structure of a CAD file in computer using data from an STL file. When the design is complete, the part is removed from the bed, which is either finished and ready to be used, cleaned up to remove support material, which is only when support material is used to build the design, cleaned up by removing raft material, heat treated prior to use. As a note, for common school printers that use plastic as the 3D printing material, options 1 to 3 apply. For metals or other composite materials, option 4 also applies. History of 3D printing. The idea of 3D printing has existed for centuries, millennia possibly. By looking at columns built by ancient Greeks, we may be seeing the beginning. François Willemay 1806's work on photosculpture was his patented technique of combining photography with the pointing machine, used by sculptors to reproduce 3D art. Here, we can see the pattern of the photosculpture, and how the idea was built. In 1980, we saw the early roots of 3D printing in photosculpture and typography. In 1981, Hideo Kodama of Nagoya Municipal Industrial Research Institute, in Japan, was first to publish paper outlining a working 3D printer. In 1984, Charles Chuck Hull of 3D Systems developed first prototype of a 3D printer. He called it stereolithography, and developed the STL file format widely used today. As a summary, 3D printing was developed in the 1980s. It was a fast and cost-effective process for industry to make parts. It was never patented by the person who invented the process in 1980, Dr. Kodama from Japan. Then, later, it was patented by Charles Hull, in 1986, who set up the company 3D Systems Corporation. In 2012, the first crowd-funded printers became available to market using the platform Kickstarter. This image gives a brief timeline of 3D printing and its technologies. In 1980s, stereolithography and selective laser sintering emerged, briefly followed by filament deposition modeling, popular as FDM, by Stratasys. In 2005, RepRap project was founded. In 2007, MakerBot was founded. Now, 3D printing is a billion-dollar industry. Modern era of 3D printing. RepRap project was founded in 2005, which was a collaborative challenge to create a self-replicating machine. Up until this point, 3D printing was very expensive and almost available only to the manufacturing industry. Beside the RepRap, what else made 3D printing more available? Cheaper technology. Patent expiration. Being open source. In 2009, the MakerBot developed 3D printers for everyone. After the success of RepRap, MakerBot made open-source DIY kits to build their own 3D printers, or 3D printed products. Thingiverse was created for users to post or download printable files for 3D designs. From the first 3D printed kidney in 2000, to the first 3D printed house in 2018, to today, 3D printing is revolutionizing big sectors such as automotive, architecture, medical and more. Types of 3D printing. 3D printing comes in 7 different forms based on its application, material, type of manufacturing. They are as follows. Vat polymerization is a method in 3D printing, to print 3D objects by using photopolymerization, which is the process of exposing liquid polymers to ultraviolet UV light to turn liquid into solids. Powder bed fusion uses a heat source, typically a laser, to fuse atomized powder particles together. This is done one layer at a time until the part is completed. Binder jetting uses powder materials and liquid binding agents to create solid and complex parts similar to powder bed. This can produce colorful parts. It uses an inkjet printer head to lay a binder onto layered powder material, and does not require heat for fusing. It is also done with ceramics, metal and sand materials, that is, granular form of materials. Material jetting is also known as polyjet, nanoparticle jetting, NPJ, and drop-on-demand, DOD. Similar to binder jetting, the print head projects many fairly large drops of ink, usually composed of photopolymers, which are then hardened by UV light. Materials can be photopolymers, metal, ceramics and wax. Sheet lamination is where thin sheets of material are bonded together, layer by layer, to form a single piece that is cut into a 3D object. Directed energy deposition consists of a nozzle, mounted on a multi-axis arm inside a closed frame, which deposits melted material onto the workpiece surface, where it solidifies. It's capable of building parts from scratch, as well as fixing complex damaged parts. Material extrusion is where a pool of thermoplastic or composite material is pushed through a heated nozzle, in a continuous stream, and deposited layer by layer to build an object. Let us get into the process of 3D printing. How does the printer operate? The 3D printing process happens when the material used for printing, such as PLA, TPU or metal, comes out of a nozzle onto the bed. The nozzle is called as the extruder. The bed is where the printer layers the material. A 3D printer's extruder moves along 3 axes. X-axis is when it moves from left to right. Y-axis is when it moves from back and forth. Z-axis is when it moves from up and down as shown in the figure. X-max, Y-max, Z-max are the maximum and X-min, Y-min, Z-min are the minimum distances. The extruder can go along those axes. Step-by-step process of 3D printing. 3D modeling. We can model an object in 3D design software, scan an object with a 3D scanner, or download an already made CAD file. Upload into Ultimaker Cura. The design file is uploaded into the Cura software, in STL or OBJ format. Format. Choose the parameters such as size, placement, print speed, etc. And material of the print. Slice and print. 3D model is sliced, that is, it is converted to G-code. Then the data is sent to a 3D printer. Here it recreates the object one layer at a time, stacking consecutive layers atop one another. Now, what is G-code? It is a specific code containing exact instructions for the printer. The 3D printing software, here, Ultimaker Cura, slices, that is, sections the model into many 3D cross-sections, and prints the material. We can see here how a 3D CAD file, converted into an STL file, is layered by G-code. Then, the model is ready to be printed onto the bed. Activity: touring the MakerSpace. Thank you.